All right, so before we start, let me show you the reference image that I'll be using. It's going to be this column that has this gradiated tile pattern on it. And so I really liked the way that this was applied on it, especially with the color gradient going from blue to white. So we'll be going over all the steps to create this one on the right. And so let's get started. First thing we'll do is create a new file, and now we need to create the column shape. So we'll create a circle, and the plane is going to be a point. So we'll construct point, and it'll create an XY plane where we can set that at a specific location in the XYZ. And now let's change the radius size. So we'll go 24. But notice that if I do 24, that's actually going to be a radius, so it's going to be 48 inches diameter. So I like to divide by 2. This way I can make sure that I'm looking at the overall diameter of the size of this. And now let's take this and extrude it up. So we'll go to extrude, up in the Z direction. And now we can use the value. So I'll go 120. That will be the height. All right, so now to create the pattern on here, we need to subdivide this. Now, there are different ways we can subdivide this, but the way that I want to do this is starting with the circle here. We're going to divide this using divide curve. Now that we have divide curve, we'll move into here. Notice that we can divide it by however many counts we want. So by default, it's going to be 10. So we'll go here to less than 3. No, 3 less than, no. 3 less than 15 less than 24. So we create a slider starting at 3, ending at 24, and set at 15. All right, so now that we have all of these points, we don't need all of the points. We only need the first 2. So I'll take this point and I'll go to list item. Notice that we pick just one of them. Now we're going to go here and go to plus, and that will actually add another one. And if you kept going, you can actually add all of them. So with this, the first 2, we're going to create, from these 2 points, we're going to move them up. So move in the Z direction. And now we can use a number. So this is going to be the size of the tile. So we'll go to 4.5 or so. We'll do the exact same thing to the other one. So now we're going to create a line segment between the start and end and start and end. So we'll go here to line, starting here, ending here. Same thing with the next one. Now we need to create one right in the middle that we need to shift up. So there are different ways we can do this. We can connect these 2 and get the midpoint, or connect these 2 and get the midpoint, or I can go to an average, which will be the average of these 2, which actually creates the center point, and same with the average of these 2. So between those 2, we have that point, and between these 2. So I'm sliding it down, tapping Alt, and now I can add this and this. So with that, we can connect another line segment, starting at the bottom, ending at the top. And notice that if we change the number of counts, that will always kind of remain there. Now we need to take the middle one and shift it outside and also shift it to the inside. So I'll take this, and to move it in this direction, we actually need to create the vector between this point and this point. So we'll go to the midpoint, or the original point, or the origin, start there, end at which one? This one. And that becomes the vector that we move this line. So using this line segment as a vector, we can use amplitude to specify the magnitude or the amplitude, and we can move this line segment using this amplitude. And now we can use a value negative and positive, so we can go -5 less than 0 less than 5.00. And this now we can use as a number to move this segment back and forth. So the idea here is that that segment can be moved in and out in the same way that if we look at our example, we have the top ones here coming out and the inside ones coming in. And so the idea is that one set is going to be offset in, one set is going to be offset out, but we also need to take this and move it up to create that diagonal. So we'll also move this segment that we moved out up in the Z direction, so we can shift it up. And we can shift it up by whatever number. So we'll go to this, copy it, bring it over here. Now we can disable the preview on the old one because we don't want to look at that. We'll look at the new one. And now it's been brought out a little bit too much. So we'll just do like 1 and up by 3. So why did we do this? Because we're trying to create that tile. And the way to create that tile is starting here, connecting here, and that next one doing the same thing. So we can do this two ways. We can loft this, starting here, continuing with this one. So holding down shift, I can add another input. And holding down shift, I can add another input. Notice that this is curved though. Now we can do two separate lofts, or we can go to options, set options from normal to straight. Then commit changes, and you'll see that rather than having to use two separate lofts, we could use one that connects this way. So let's take a look at what we've done so far, which is look at our subdivisions, then look at the height of that module. Let's go to the next one. The depth of it, in or out, and the height. Now I want to keep these at numbers that are simple numbers, so we know what we're working with. In the extrusion, we have not, if you think about it, we haven't used it. All we're using it for is as a reference to know where we'll be applying this. All right. So now that we have this entire thing, let's clean it up a little bit. Wire display hidden. Same with this. And the reason why I do that is to clean it up, make it a little bit more, a little bit easier to understand. So from that, we create this. So check it out. If I were to do this, so this entire script here creates this module right after we have the points. Now, what if we took all of this and we copied it, but we did not copy any of these except for the amplitude one, and you'll see why. So I'll take this, slide it down, tap Alt, and now we can have one that offsets out and one that offsets in by -1.5. The reason why, and you'll see this, is let's keep this as the original, so we'll hide this one. We will also hide the line segments that create all of that, except for the module. And now we can do a calculation to be able to array this. Now there are two ways to array this, one using polar array and the other one using series. I typically use series, so in this case I'm going to use polar array, which lets you plug in a geometry. What's the geometry? The loft. Where is it going to be arrayed at? Well, we know we have this point where it was created. The count is going to be the exact same as the count for the number of points. And the angle is going to be 360 by default, or 2 pi. But we don't need to change this because this is what actually allows you to have a full pattern going all the way around. So with this, now we have one array. What if we did the same thing, move it down, so tap Alt with this one. Now they're going in. So what we need to do is move this up. But here's what we need to do. Let's turn them into tiles before we do that. That way we don't have to extrude a bunch of stuff. So before it's even arrayed, this needs to be extruded in the same direction as this line segment. So we'll do that. Extrude. We'll use this same amplitude, copy it over, plug it into the direction, and now we can extrude these in that direction by 1.5 or whatever. So let's go here to 0 or whatever size you want. So there's this. And now we're going to array that. So it's extruding out, and now we'll be doing the exact same thing to this one. Okay. All right. Now we need to take the set that's offset in and push it up by the same amount as the height. So move all of this in the Z direction by the height of the tile, which is here. And disable the preview on the previous one. And all of this. Now let's take a look at the amplitude of this and the offset amount. So if this is negative, then this is positive, or it's actually this one. So now we can use positive number and then multiply it, or use a negative. So we use a minimum and maximum kind of number here. Why? Because whatever number the tile is offset by is how much it should extrude by. So if we extrude this by one, and we also offset this by 1, well, if we do 0.5, half of the depth of the tile, you will get no overlaps like this. So now that we have this set of tiles arrayed around both here and here, this becomes one module, right? So then if I copy this up and up and up, then we'll get the exact pattern that I was looking for. Now the cool thing about this, and I've mentioned this multiple times, is we can make this tighter, make it a little bit more loose, and we can see all the changes here as we change the counts, right? Because that's the thing that makes it, you know, array. Okay, let's move over. So the other thing that I was just thinking here, if this is 1, right, how much it extrudes, and this is 0.5, couldn't we do 0.5 times 2? Or multiplied by, yeah, times 2, and we can set the gap amount as what's important, and then here the tile size is really what would change. So if I offset this more, it would extrude more, but there would never be a gap, and that's kind of the idea here. That if this is 1, the tile size is 2. We can also do it the opposite way. So let me show you what I mean. If the important thing here is the tile size, if I want the tile size to be 1, well then we do 1 divided by 2, and that would be the value used for all the offsets. So it's the same thing, it just matters what functionality you want. Do you want your offset to be the important thing, like to be the extreme, or do you want it to be the tile? Like if you have a tile that's 1/2 inch, how much do you need to offset that by to create that gap there? All right, without talking too much, let's get into the arraying it. So I'll plug both of these into the geometry input here and flatten it. And what this does is put this all into one component. And now we can take these two and create a vertical array. Now, how do we do that? Move. In which direction? Z direction, up. By how much? Well, we know this tile size is 5.2. And if I do that, we know we're halfway there. So I have to do that times 2. So that number times 2. And then disable the preview on. So we got that. This one. But what happens is the reason why it's only doing one copy is because it's only giving us one number. So to add more than one number, we need to use the same value coming into the Z, but we need to create more numbers using the series component, which is one of my favorites. What we need to do is tell this component how to create more than one number, but we need to tell it what number. So the number is going to be 10.4. The count is how many? Let's say 5. And so it creates 5 numbers, stepping by 10.4. And so with those numbers, now we can plug them in here. Now here's the trick. When you plug them in, it won't work because of how the information is organized. If I graphed the input, it will make sure to place those numbers to all of those tiles. And now we can array this vertically. So let's go here to say 20 for max. And the variable is this one. So if we said, let's make the tiles 1.5 inches, concrete tiles. And now that we have that, let's take these and let's give them a color so we can see them a little bit better. So now this moves into not just the design, but also how are we going to create the gradient. So now here under materials, we'll go to swatch or color swatch, and we can now look at this a little bit better. And if you want to double check, you can also middle click and bake, bring this out here and do a clipping plane. Let's take a look at this using vertical. So we can look at this as a vertical section here. And they are perfectly tiled. Now this is not taking into account, let's say, the grout lines, if they're not stacked on top of each other without grouts. But now that we have that, and we can see it clearly, or actually, let me bring this back and do one last check. We'll go to ray traced, see what it looks like here. All right, next, let's create the gradient. So for this gradient, we need to figure out where these are located relative to, these are also extruding out. Let's see if we can extrude them in. One last thing here. Okay, so let's see if extruding it by the negative direction, it actually closes down some of those gaps. Yeah, by extruding it in, it gets rid of some of the gaps. So that's this one. But what we need to do is figure out how these are arranged in the vertical direction. So if we take all of these objects and we go to an area component, each object, let's hide this, each object is going to have a center point. So that data of the center point is going to be deconstructed. Now we need to flatten the input here. And now we're going to deconstruct where those points are located. So if I take those centroids, I can see where they are relative to the Z. So starting at 3, ending at 113. We can also use bounds to figure out the minimum and maximum. So I'm bringing in bounds and then quotation marks to bring in a panel, and we can see the minimum and maximum for this reason. When we create a gradient, we need to change, right? And the change is in the Z direction where the gradient happens. So now let's bring in a gradient. What's the lower number? 3. The bigger number, 113. So now we can also deconstruct. Let's see. Or construct, let's see here. deconstruct domain. With deconstruct domain, we can take bounds and we can figure out the start and end. We can also plug this one in, it's the same thing. Now we can use that start as the lower limit and the end as the upper limit. Now we need to pick a number between 3 and 113. So let's just, create a slider between 3 and 113 and use that as a parameter. Now the color is obviously going to be the default one here, but we are going to be able to change that. So now we'll override this and let's take a look at it here and also flatten the input. Now we'll be able to look at it like this. Now let's change the presets here. Actually, it's going to be this one. The Z component has to go into the domain here to bring in all the numbers. Now with this, we have the ability to create the gradient. And not only that, but we can bake this information into the... So if you bake that custom preview, you go to rendered, you'll see all of the tiles there. Okay, now let's go back to shaded and let's create a custom gradient. So I'll go to gradient, double click here and select the object. Now this is the bottom part. So we'll go here to white or blue, actually. We can pick the color here, or if you, let's see. There are different ways to pick it. You can do custom, web. Now, if you go to web, it actually has names. So if I go down here and I say, okay, the color is going to be Dodger blue. Dodger blue. And this is going to be white. Or see how, just white. Okay. All right, let's use this one. Start limit, end limit. And it's doing it backwards. So we can either flip the min and max and then change this where we want that located. Okay. That's looking good. Let's see here. I see what happened here. So these are individual or these are actual full objects that are extruded out. I'm trying to see if here's what I think makes it look better is if it does actually have the grout lines. So the idea on that is we're extruding these lofts, which are put together. If we explode them and we explode, actually deconstruct, and now these are going to be perfect because now we can use those as the extrusions, but also because we can scale those down. So if I bring in an area component Now, area does have some discrepancies between Rhino 8 and Rhino 7. So I try not to use them as much, but we'll get the center of each face, and we'll also scale the face relative to the center point. Now, obviously some of these colors are getting in the way. We're talking down here. Okay. So if these get scaled down by that much, by 0.5, we need to do a little bit more. Let's say 0.88. And that's going to be kind of the grout. So if we do this, not just to this one, but also to the top and the bottom, then we can extrude those. And now they've been arrayed with a bit of a gap. So now let's take a look at this. I think this will look better. The reason why, like I said, is because when they're all together, you don't see the gap of the grout. And I think that's part of what makes this successful. It's not that they're just together, is that there's a little bit of a gap here. So let's take a look. And let's, much better. And this is why I love parametric design. Notice that we had already kind of finished the script, but I saw some discrepancies and I knew exactly where in the script I had to interject to be able to get these exploded and extruded independently, but also scaled down, because I think this just looks so much better. So if one is no scale and 0.9 is with a gap, now let's bake this. Much better. And if we looked at it in rendered view, we have all of the materials and the colors. Now you're gonna ask, what kind of materials are these? And the truth is that these are Rhino materials. So if we look here within Rhino and we look under materials, you're now going to have a long list of colors. Now, some of these colors were from the old bake. So if I go to purge, materials and layers, these are the only colors that we have. So we can change these if we want here, or we can get the color information that we want from it. So if this number is something you want to change, or you want it to be something specific, those are the things that we can do. So with that being said, I think that concludes that portion. So what I'll do now is I'll clean this up and get this to a point where this is something that you could download and use yourself, and also see how this all came together. So I'll be doing that right now. And if you want to download this, you can go to my website, capettidavid.com. I'll have it available for you to download for a limited time. I now also have other tutorials and other resources if that's something that you're looking for. So thank you very much for being here. Hopefully you found this interesting and useful, and I hope to see you on the next one.